Alright guys, so here are my notes on finding distance between points. Our goal today, after you leave here, you're going to be able to find the distance between two points or coordinates on the coordinate plane. Now the type of problem you're going to see on your test, especially your iReady test, is one like this one below, where it says find the distance of this line segment below. So A to B, and it wants us to find how far it is from here to here. Now, it's impossible to do it by counting because these aren't nice blocks. It's going by halves and stuff like that. So there's actually a formula that goes along with it. Now, the formula that goes along with it, I went on Google and I just typed in distance formula, and one of the first things that popped up, as you can see, is right here. Looks nasty. And actually, the first time that I did this, I was in 10th grade. But because you guys are smarter, and I know a better way to teach it, I'm going to teach it to you now. So what you're actually doing is finding the distance between points A and B. Now, it might be strange that I'm asking you a distance question when we are in a chapter about Pythagorean theorem, but you can actually use the Pythagorean theorem to solve this. Can anyone figure out how? Why don't you take a look at it for a second and see if you can figure out how. Well, if you couldn't figure it out, all you need to do is, well, what does the Pythagorean theorem talk about? So hopefully you said triangles. Could I make a triangle out of this? Ta-da! And is there a right angle in this triangle? And is there a hypotenuse in this triangle? And could I count how long each one of these sides are? 4, 5, and I'm pretty sure you guys could count that one as well. So what we're going to do is we are going to make a triangle with the line they give us. Okay? So on the next page, I say, answer this question from the first page. Let's figure out the distance between A and B. Or let's figure out how long this line segment is between A and B. All right? So we are going to make a right triangle out of it. And I'm going to count how far or how long this side is and how long this side is. 1, 2, 3, 4, 5, just like I said before. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So now what I'm going to do is I'm going to use my Pythagorean theorem, a squared plus b squared is equal to c squared, and plug into here. Now this side right here, is this side going to be a b, a c? What is it going to be? Well, because my right angle's right there and it's pointing to it, that has to be my hypotenuse. That has to be my c. So the thing I don't know is my c squared. That means 5 squared is a and 12 squared is b. And I'm pretty sure I could do most of this off the top of my head. 25 plus 144 is equal to c squared. 25 plus 144, 5 plus 4 is 9. 4 plus 2 is 6. 1 plus nothing is 1. So 169 is equal to c squared. And the square root of 169 is 16, root 13. So the distance between A and B on here is 13. 13 what? It really doesn't say. Okay? So not all distances are going to come out nice. When that's the case, just leave it as a square root. Or round it off to the spot that they tell you to do so if they tell you to round it. So let's take a look at another question. So it really doesn't matter how you make your triangle here. You could make it like the purple one I just showed, or you could make it like the green one. It really doesn't matter. Why don't we do the purple one because I did the green one last time? Because they're both going to end up being the same side lengths no matter what. So this side is 1, 2, 3. This side is 1, 2, 3, 4, and 5. Again, here's my right angle. So the side I'm looking for is my hypotenuse. So when I plug into a squared, b squared, and c squared, my 3 squared goes there, my 5 squared goes there, and the c is the thing I don't know. 9 plus 25 is c squared. 9 plus 25 is 34 is equal to c squared. Square root both sides in order to get rid of the square, and c is equal to either the square root of 34, or if they ask you to round it off, say to the nearest tenth, it is 5.8. So either square root of 34 or 5.8. Okay, guys? So hopefully that's pretty easy for you. On the next page, I have you trying one. So would you please do that for me right now? Pause the video while you're trying it, and then unpause it when you are done. All right, so hopefully you had enough time. Obviously, just like we did the last two times, we're going to make a triangle out of this, and a right triangle. I can see it right there. Or you could have made yours down here. This side length is going to be 1, 2, 3, 4, 5, 6, 7. This side length is going to be 1, 2, and 3. Just like always, it's going to work out like that for all these today. That this is our C. So 3 squared plus 7 squared is equal to C squared. 9 plus 21 is equal to C squared. 9 plus 21 is 30 is equal to C squared. Take the square root of both sides, and I get either the square root of 30, or, let's round it up to the nearest tenth, 5.5. Make sure you said 5.5 instead of 5.4. All right, so let's move on to this next thing here. So if I had to guess on the state test how they're going to ask it, they're going to ask it just like we just saw. In fact, I've seen this on the iReady test a couple times. But if they want to make it harder, or like the types of questions I saw when I was in 10th grade, it was more like example 3, where it says find the distance between -2, 4 and -5, -6. Now at first glance, this looks harder because there's no graph. So I'm thinking that they might just give you a blank graph under the question, where you should just plot the 2 points. If they don't, you need to make a graph yourself. The nice thing about your tests next year, though, is they'll typically give you some blank graph paper right at the very end of the test. So on the next page, I have a blank graph for us, and we're going to graph -2, 4 and -5, -6. So let's do that right now. -2, 4 and -5, -6. So what it wants us to do now is find the distance between these 2 points, or find how far it is from right there to right there. And in order to do that, we're going to create our own little right triangle. Remember, it doesn't matter which way you create it. I'm going to go like this. I'm going to count this side to be 1, 2, 3. This side to be 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And plug into my a squared, b squared is equal to c squared. So 3 squared plus 10 squared is c squared. 3 squared is 9. 10 squared is 100 is equal to c squared. 9 plus 100 is 109. So my answer is, after I square root, c is equal to either the square root of 109, or if I want to round it off to the nearest tenth, 10.4. All right? So why don't you guys try one just like that, where you have to graph the 2 points. Again, pause the video and unpause it when you are done. All right, so hopefully that was enough time for you guys to try it. -7, 4 is right here. -3, -2 is right there. Let's connect these 2 points with a nice line. Let's make this triangle and count up these side lengths. I get 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. So again, let's plug in. 4 squared plus 6 squared is c squared. 16 plus 36 is c squared. 16 plus 36 is 52 is equal to c squared. So my answer is either the square root of 52 Or if I wanted to round it off to the nearest tenth, 7.2. Okay, so the distance between these 2 points is 7.2, or the square root of 52. So other than some final thoughts, that's it, guys. The Pythagorean theorem helps us find the distance between any 2 points or coordinates on the coordinate plane. Remember the Pythagorean formula: a squared plus b squared is c squared. Blank is the hypotenuse. C is the hypotenuse. Now remember, this is even more important than the biggest side. It's the side opposite the right angle. And if they don't give you a triangle, like they didn't today, just create one yourself. Use right angles. All right, guys, that's it. Thank you so much for watching, and yeah, that's it.